Hi everybody. I'm sorry I can't be there in person today, but we'll still be able to talk about phase diagrams. A phase diagram is a graphical representation of what happens to a substance as it goes through the solid, liquid, and gas phase. We remember that a gas has more energy than a liquid, which has more energy than a solid. So on the x-axis is the temperature scale. As temperature goes up, we go from solid to liquid to gas. On the y-axis is pressure. We tend to live at approximately 1 atmosphere, but we can artificially change the pressure, and so that's represented on the y-axis, and we can see that different phases happen when we change the pressure as well. So, oops, wrong button. We can actually see that as we increase the pressure, we can change from a gas to a liquid to a solid. So there are several vocabulary words that I want you to be able to know. So let's take a look at those. There's the sublimation curve, the fusion curve, and the vaporization curve. Those are sets of temperatures and pressures at which we will have sublimation or deposition, melting or freezing, and boiling or condensation. So let's take a brief look at those again. So in the fusion curve, I can pick any temperature on the x-axis. Let's try to make this stop moving. And any pressure on the y-axis. And if they intersect on that curve, that's a temperature and pressure where melting and freezing can happen. It normally happens at 1 atmosphere, right about here. We can do the same thing with the vaporization curve. I can pick any temperature and any pressure that fall on this line. That's a point where the liquid will boil or the gas will condense. There are also two special points. A triple point, which is a specific temperature and pressure at which the solid, the liquid, and the gas all coexist together. And they stay that way. They're not melting, they're not boiling, they're not freezing. They're just staying a mixture of solid, liquid, and gas. And the critical point, which is a unique temperature and pressure above which liquids don't exist. We don't typically see those because there aren't really substances that have a triple point or a critical point at the normal atmospheric pressure at which we live. But they can be easily done in a laboratory. So for iodine, which is the curve we're looking at, we can see that there's a critical point up here and there's a triple point down here. So let's see if we can answer some questions about this graph. The first thing I want you to do is find the temperature and pressure for the triple point. So look at the graph and see if you can read them. Your paper also says critical point, but we won't have that information. Did you find it? If you look on your graph, you should see 114 degrees C and 0.111118 atmospheres. 0.111 ATM, 114 degrees C. All right, now pause the video and see if you can answer questions 3 through 8 using these choices. All right, are you ready to take a look at it? So if we go from point A to point B, we're going from a liquid to a solid, which means we are freezing. Density increases. And so the solid has to be more dense. Most materials have a solid that is more dense than the liquid. Let's take a look at D to G. D to G, we're going solid to gas, which means sublimation. C to B. C to B, we can see that there's two changes. We go from a gas to a liquid to a solid. So we can see that we condense the gas and we freeze the liquid. As we go from A to G, let's just get rid of that line altogether because we don't need it anymore. A to G, we're going from a liquid to a gas, which means from liquid to gas, we're boiling or vaporizing. Parts E to F. E to F, that's the vaporization curve. And E to H is the fusion curve. This is the fusion curve, so it's freezing and melting. So given a graph and the information in the graph, we can interpret the graph and look at the data. So let's take a look at the next graph. Pause the video and see if you can answer the questions. When you think you're done, we'll take a look at it. All right, you think you're done? Let's see if we got the right answers. At normal pressure, the freezing point is 0 degrees Celsius, and the boiling point is 100 degrees Celsius. That was pretty easy because those are the only two temperatures on the scale. Let's take a look at the physical changes. As we go from point A straight up to point B, it's tough to see, but there's a little bit of deposition, gas to solid, and then solid to liquid melting. We know that as we move up in pressure, we increase the density. And so the solid has to be less dense. As we increase the pressure, this section right here, B, is more dense than this section right here. That's a reflection of the fact that water is a very strange, unique substance, and it's one of the only substances where its solid is less dense than the liquid. So let's turn to the next page, and again, we're going to pause and try to see if you can answer the questions. Okay, are you ready to take a look at the answers? If so, let me get rid of this little Heidi screen. So those are the 6 phase changes, and you should be able to do that because that is straight from your notes. State of matter with the most kinetic energy. Again, we've talked about that before. Solid has the least energy of motion, then a liquid has more energy of motion, then a gas has the most, so it has the most kinetic energy. Its molecules are moving the fastest. And then we'll take a look at the phase changes as endo or exothermic. Here are 6 phase changes. When we go from a solid with low energy to a liquid with higher energy, we put energy in, endo, and the reverse is exo. If we go from a liquid with medium energy to a gas that's high energy, again, energy goes in. And sublimation, going from a solid with low energy to a gas with high energy, is endo, energy in. For the states where we go from higher to lower energy, energy has to leave, so it's exothermic. So those are some of the things you can do with a phase diagram, and you can take a look at the phase changes and the amount of energy. So now you should be ready to try any sort of problems reading a phase diagram. If you have questions, be sure to let me know when I get back. Thanks.